Hello, Ante Matric. This is your AP test memo walkthrough from the 13th of July. As you see, there's a timestamp that accompanies this. So I think what you need to do is not watch the whole video. You need to have marked this first with the memo that's on Teams and then skip to the questions where you need help. So if you haven't done that, then stop the video now, go back, go through the memo and as well as the test that you've done, see where you've gone wrong. And from there, once you've done that, you can come back and watch the video. Okay, firstly, I know that a lot of you do not read instructions. There's an instruction that came before question 1. In this whole section, round off your answers to 4 decimal digits where appropriate, unless stated otherwise. So you must remember, particularly in stats and in modeling, we often need those decimals to be rounded off to more than two decimal digits are not enough, because otherwise the probabilities are too close to each other. So you really need to watch out for that. You do get penalized. Question 1.1. The probability that a student is accepted into a certain university is 0.35. If 7 students from Roedean apply, find the probability that the university accepts all 7. I hope you've got your question paper with you as well, so you can refer to the question while you're watching this. So this is an example of binomial distribution, because we have 2 different outcomes here. They're either going to get accepted or they're not. So I've let x, my random variable, be the number of students accepted. Remember, whatever you let your random variable be should always be the thing that the question's asking for. So if they're asking for the university accepting all 7, then you're going to let your random variable equal the number of students accepted. All right, so in our probability equation, we've got our random variable x equals 7. And in our combinations formula, we've got 7 at the top because there's 7 Roedean students that have applied, and from that choose 7. All right, because we want to look at what would happen if all of them apply. Now remember that this 7 choose 7 can also be shown as 7 choose 7. All right, you've seen it in both ways. Okay, then our first probability here is the probability that they'll be accepted. Now if we're saying that all will be accepted, then the exponent must be 7. And the exponent of the probability of them not being accepted will be raised to the power of 0, because we're expecting all 7 to be accepted, right? And that's 0.0006 marks, probability for 3 marks. B, hence determine the probability that at most 2 girls are accepted. Okay, in an at most question like this, it's easier to look at the probability that our random variable is either 2, 1, or 0. So if at most 2 girls are accepted, then 0 girls could be accepted, 1 girl could be accepted, and 2 girls could be accepted. So we have to add the probability that our random variable is 0, or plus our random variable is 1, plus our random variable is 2. Right, so the probability that none of them will be accepted, we then have 7 choose 0, times the probability that they'll be accepted, 0.35, is now raised to 0, times 0.65 raised to 7. Remember that these 2 exponents here must add up to your total, your random variable at the top here. All right, and then the probability that 1 is chosen, we now have 7 choose 1. In other words, 1 of the girls out of the 7 from Roedean are chosen, and that 1 is there in the exponent with the 0.35 probability she'll be accepted. And then again, 1 plus 6 adds up to 7. And then lastly, 7 choose 2, and we now have the probability that of 0.35 that 2 of them will be selected, and then obviously 5 is the exponent of the 0.65 to give us 0.5323. All right, obviously a lot higher odds that at least 2 girls are accepted than all 7 girls. Sorry, that at most 2 girls are accepted, then all 7 girls. All right, 1.2a. Boikanyo must write a true or false test, and it's on ancient Latvian literature, and we know that Boikanyo knows nothing about ancient Latvian literature. So the test has 40 questions. Right, A, determine the probability that Boikanyo doesn't get any answers correct. Round off your answer to 13 decimal digits. You must have thought, why the hell is this man asking for 13 decimal digits? Okay, but then when you saw your answer, it made sense to you. All right, so the probability that she doesn't get anything answered correct, I should have said let x equal the number of answers correct. So defining our variable, probability of random variable x equals 0, we have 40 questions from which we're choosing none. And the 50-50 here comes in because you've got a 50-50 chance of getting it right. You're either true or false. Okay, there isn't anything more to it. So 0.5, which represents the true or the success, is 0. And then 0.5 representing the failure or getting it wrong is 40. All right, so your calculator would have given it to you in scientific notation. It was 9 comma something times 10 to the negative whatever. So we needed to see that you could express that in decimal notation. B, what is the probability that Boikanyo answers 25 questions correctly? Right, so we're doing the same structure, except now we're looking at x, our random variable, equal 25. We're looking for 25 correct answers. So in our combinations formula, we have 40, choose 25 this time. And remember, this number here and that number are always the same in a binomial distribution. All right, and then this number and that number must always add up to that number. Right, so 0.5 successes will be to the power of 25, 25 right, times 0.5 to the power of 15 failures. Okay, to give you 0.0366. Question 2. At tea time, there were 15 girls from lambs and 18 girls from bears sitting on Bears Terrace in the rain. There were no girls from cats because they don't like the rain. 2 girls, one after the other, decided they no longer want to sit in the rain and went upstairs to the relative comfort of Mr. Taylor's empty classroom. 2.1. What is the probability that both the girls in Mr. Taylor's classroom are from lambs? All right, so this is a hypergeometric distribution because we've got a whole lot of different things happening here. And so we're going to let our random variable x equal 2. All right, those are the 2 girls from lambs. In other words, x is the amount of girls from lambs. Okay, so in our numerator, we have, firstly, there are 15 girls, and we want to choose 2 of them because we're looking at the probability that there are 2 lambs that go to Mr. Taylor's class. The remainder of the girls are 18 of them from bears, and we want 0 of them because we don't like bears. Right, and then in the denominator, we have the total, 33, which is the combination, the sum of 15 and 18, over 2, the amount in total that we're choosing. All right. Now, some of you skip the step out, but I think it's important that you put that fraction step there, simply because you're often asked to leave it in fraction form. So please try and keep it in. All right, and then lastly, 0.1989 is your probability. Question 2.2, determine the probability that at least one of the girls is from lambs. All right, so with this one, it's quite complicated to do it just on its own, that at least one of the girls is from lambs. So the easiest way to do that is to look at the probability that our random variable is 1 or more, but we subtract the probability that none of them are lambs from 1, okay, because remember they're mutually exclusive. All right, so 1 minus the probability that none of them are lambs will give us the probability that at least one of them are lambs. Okay, remember, because it can be 1 or 2 girls. So we're looking basically for when are they not any lambs, when are they both bears, and that's what we're subtracting from 1. Right, so substitute in, we've got our 15. Remember, we're saying 1 minus the probability of 2. So this whole fraction here looks at if there are no girls from lambs. So 15, choose 0, 0 girls from lambs, times 18, choose 2, 2 girls from bears, over 33, the combination of both houses, choose 2, which gives you a 0.7102 chance. Question 2.3. If 4 further girls join the 2 girls already in Mr. Taylor's classroom, determine the probability that 2/3 of the girls in the room are from Lamb's house. All right, so now we're looking for the next 4, okay, because there are 6 girls in total in Mr. Taylor's class now. The 2 original plus the next 4, total 6. And 2/3 of 6 is 4. So we're looking at the probability that there are 4 lambs in Mr. Taylor's class. Okay, so this time, our random variable x equals 4, because we're looking for 4 lambs. So out of the 15 lambs, choose 4. That means the remaining 2 must come from bears. So 18, choose 2. And then in the denominator, 33 is the sum of the lambs and the bears girls, and 6 is the sum of all of the girls in the class. So 33, choose 6, and that gives us 0.1886. Okay, one thing I also picked up, please remember that in between these two here, the operation is multiplication, not addition. Right, girls, that's the end of section A, 33 marks. Section B, finance and modeling. And we're on to question 3 now, 3.1. All right, I'm not going to read the whole blurb about the pigs, the first paragraph. But on the second paragraph, that's where the important information is. Okay, that a sow has 2 litters a year, each with an average size of 6 piglets, 57% of which will be female, and the survival rate of the piglets is high at 84%. Okay, so remember, let's look at question 3.1 and come back to that. Calculate the annual growth rate of the pigs and round your answer off to 3 decimal places. Right, so the growth rate, remember, is the birth rate minus the death rate. And for the birth rate, you need 4 things. Okay, so that's where that second paragraph comes in. You need the 2 litters, so that's 2. You need the size of each litter, so that's 6 piglets. The percentage of which will be female, 57%, and the survival rate, 84%. And you multiply all those 4 together, and that gives you the birth rate. I haven't expressed the birth rate here explicitly, but it is there within the B minus D. And then the death rate is 1 over 6. Okay, just remember why 1 over 6. Anything that lives longer than 1 year, we express the death rate as 1 over however many years they live. All right, so because the pigs live on average for 6 years, their death rate's 1 over 6. So our birth rate minus the death rate gives us the annual growth rate of 5,579. 3.2. Express the growth in the pig population as a recursive formula using an annual growth rate of 5.6 pigs per annum. All right, so this is quite straightforward because you've done the recursion in grade 10. This is the formula that you need to start with. All right, it's given to you on the information sheet. And how do we know it's recursion? Because we have a population multiplied by some form of rate, which will give us the next population. Okay, so in other words, to work out Pn plus 1, we need Pn. That's how we know it's recursion. All right, so they've given us the growth rate to use, 5.6. And we just need to add the 1 effectively and get 6.6 Pn. Please don't leave it at that second step. That's not simplified. You must go through and leave it as 6.6 Pn. 3.3. Calculate the pig population after 3 years on a certain farm. If there are currently 22 pigs on the farm, use the same growth rate of 5.6 per annum. One thing to point out here, please, is that you must use recursion unless you're told otherwise. So do not do it explicitly. All right, because you get marks for each population, especially if there are only 3 years you have to work out, you're going to get marks for all the populations. Okay, if you're asked to work out 20 or 30 years, you'll get marks for the first few. And the reason why you write the first few down is so that you can see that you're on the right track. It's growing in the correct direction. All right, so a couple of important things. You must start out with your formula, and you must show what population 0 is. This recursive formula on its own is useless without a starting point. Okay, so there wasn't a mark allocated here, but there normally actually is. So you're quite lucky if you didn't lose that mark. All right, then the next important thing is you must show P1 with your substitution of 22. All right, you must show that substitution and the answer to population 1. After that, you just put the answers. Population 2, population 3. Okay, so 6,324,912 pigs. So that is going to either be 6,325 if we strictly round up, but we actually would accept you rounding down or up because it's a model, it's not exact science. Question 4, the growth of a certain species of wild cat is represented below. Right, so here you do need your question paper in front of you in case you didn't get these right. But to calculate A, you need to look at the number of cats population, and you take the population after A and the population before A, and you divide by 2. Okay, so the 2 is effectively the difference in years. So if the first one, 13 minus 6 over 2, gives us 3.5, and so on for B and so on for C. And I think some of you, I saw typics here, etc. Some of you got confused that it was the same. It's absolutely fine for it to be the same. Because remember, it reaches a point of inflection and starts to level off again. Okay, so that is absolutely fine. All right. So letter D, E, and F. So for letter D, E, and F, it's simply delta population over population. So you're going to have your 4.5 over 24, which gives you 0,1875, 3 over 28, and lastly for F, 2 over 30, which gives you 0,0667. Please watch your rounding here. We were strict because it actually did ask you to round off to 4 decimal places in this section. So please make sure that you've done that correctly. Okay, question 4.2. Use the regression function on your calculator. This one you either know it by now or you don't. If you've forgotten how to do it, then go and consult your Ante Matric core lovely color-coded stats notes that Mrs. Graffley put together. But again, rounding off is important. They asked for 3 decimal places. But also one point I want to make here is they asked you to work out the line of regression if the values of delta P over P were plotted against P on the scatter plot, not Y against X. So strictly speaking, your line of regression needs to be in terms of delta P over P and P, not Y and X. 4.3, the number of the cats in the table above were only estimates. However, P0 is accurate. Write a recursive formula for the model represented in this table and use it to predict more accurately the number of wild cats in the reserve present after 6 years. Right, so it's a logistic curve, and we need our R value, which is 0,619. And just a word on that, how we know that. The constant in your delta P over P equation. Okay, so remember that's the graph that looks like this. When you have delta P over P on the y-axis and you have population on the x-axis and you have your graph going down like that, R is the y-intercept because that's the maximum growth rate and K is the x-intercept. Okay, so this question relied on you getting 4.2 right, and so that's I think why 4.2 is quite heavily weighted, 2 marks each. But you needed to get that right. So your R value is your y-intercept, and your K value, 34, is your x-intercept. But now remember, 34 has to be a natural number. So it's not a decimal. You're never going to put a decimal into this denominator here. Okay, so remember that. 34 is not the exact x-intercept of this function, but it's the rounded off. All right, so into our logistics curve, we have our initial population of 6 cats, and so there's our 6 cats, the initial population, plus R 0,619 times that population of 6 cats, and into 1 minus the population over your carrying capacity. Okay, so remember when you're working this out, you're going to push 6 equals, that goes into your answer, then you're going to be answer plus 0,169 times answer into 1 minus answer over 34 equals, and we get 9,06. Do not round off yet, you're not done. Okay, equals to get to 2, population 2, equals to get to population 3, and then I've left out a few, and then to population 6, 31,01, which gives us after 6 years 31 cats. Question 4.4. Is it fair to assume this cat population will continue to rise exponentially? Right, now one thing I want to point out here is that we were not looking for a general kind of criticism of the flaws of a Malthusian model. We were looking for you to specifically use the words carrying capacity, because it says, is it fair to assume this cat population? So it's referring to this model, which is a logistic curve. Okay, so generally when you're asked to recognize a logistic curve, they want you to determine whether there's a carrying capacity or not, because that's the main difference from a Malthusian model, which would assume that the population would continue to rise exponentially. Okay, so no, carrying capacity is only 34 cats. You could have also said the growth will slow down, because that's what does happen after the point of inflection in the rise of population. Question 5 is straight substitution. A certain model has a carrying capacity of 130 and an initial population of 58. 1 cycle later, the population has reached 64. Calculate the intrinsic growth rate. Okay, so we start off with our general formula, and remember again, with Pn equals 58, substitute in our next population, 64. Our initial population now 58 plus 58R, we're solving for R. Straight into the formula on the formula sheet, into 1 minus our population over the carrying capacity, and solve for R, 0.19. And remember, some of you put it in as percent form, etc. It's not necessary. It only asks you to give a rate. So it's perfectly fine to leave it in decimal form.